guys, welcome back. So in this video we will see the second technique for race-free state assignment. So this technique is called as one-hot state assignment technique. So let's get started with the help of a small example. So let me draw a flow table, an example flow table. So let's take an example of the flow table. On your left hand side you have all the present states, and the top header consists of the inputs. Then the values inside the cells will represent the next state. So we are to assign some binary values to these states. So I have 4 states A, B, C and D. So we are supposed to assign binary values for them, making sure that it is race free. So this one hot state ascent is a new technique what we follow. Previous to this we had another technique called as shared row state assignment. We had a different methodology. So in this one hot state assignment methodology, we are going to assign states in such a way that every variable will have a binary value assigned to it. So the number of bits in that binary value will be equivalent to the number of states totally what we have. So for example, in this problem we have 4 states. So the number of bits that are going to be assigned to every state here will also be 4. So we are going to assign values for A, B, C and D. So the number of bits for all these 4 states will be 4. And we make sure that one bit is always active in that assignment. So what I mean by that is, so let's take an example for A, which is 0001. So for B I can give 0010, for C it is 0100, and finally for D it is 1000. So if you see, all 4 values are unique and they are not repeated, and also only one bit is active, which is carrying a value of 1. So the number of bits in every state is 4. So the number of bits is dependent on the total number of states what we have. So in this flow table, the total number of states is 4. So the number of bits of state assignment is also 4, and only one bit is active in that assignment. So this is the first step what we follow in one hot state assignment. So the first step, we assign a random value. In the random value we follow these strategies. So the number of bits is equal to the number of states and one bit is active. Now after doing this, let's draw the state transition diagram in order to find out whether there exists any race condition. So let me draw the transition diagram first. So if I draw the transition diagram, so I'll be having A, B, C and D. So the first row, A to A is possible, A to B is possible. So A to B, I'm just leaving or discarding the self loops. A to C is also possible, A to C, and the last one is also A to C. So now moving to the second row, B to A, B to B, B to C and B to D. All transitions are possible. B to A is possible, B to C is possible, and even B to D is also possible. And the third row, C to A, C to B, so C to A, C to B, and C to C, finally C to C. So the last row, D to D itself, D to B and D to C. So D to B, this is also possible, and D to C also possible, and the final column is D to D. So we leave it as it is. So this is the transition diagram what we have. So let's check whether there is any race condition in this transition diagram. So according to the assignment what we have made, this is 0001, this is 0010, this is 0100, and finally it is 1000. So from A to B, so that is 00001 to 0010. So first bit is not changed, second bit is also not changed, the third bit is changed, it is 0 here, it is 1 here, and the fourth bit is also changed. So I have a race condition. Similarly, let's talk about B to C. So if I go for B to C, so that is 0010 to 0100. So first bit is not changed, the second bit is changed from 0 to 1, the third bit is also changed from 1 to 0. So this is also race condition for us. So I'll just mark the race conditions. So this is a race condition, this is a race condition. Now let's talk about A to C. So A to C is 0001 to 0 1 double 0. So here one bit no change, the second bit is changed, third bit is not changed, the fourth bit is changed. So here also we have a race condition. So this is also possible. And the final is B to D. So when I speak about B to D, it's 0 0 1 0 2 1 triple 0. So the first bit is changed, second bit no change, third bit is changed. So this is also a race condition for us. So you'll mark this also as a race condition. The final loop is D to C. So if you speak about D to C, let me write it here. D to C is 1 triple 0 to 0 1 double 0. So first bit is changed, second bit is also changed, so this is also a race condition. So ultimately all the connections here are race conditions for us. So how do we solve this race condition? So that's why we move to the next step. So in your step 3, we have a race condition from A to B. So we are going to introduce a new state between A and B. So wherever we have a race condition, introduce a new state. Now how to form this new state? We will follow a specific strategy. So I need to find a new state between A and B. So this new state, let me call this as E, for example. So E is formed with the help of A and B. So first I will write down what is A. A is 0 0 0 1. B is 0 0 1 0. 0 0 0 1 and 0 0 1 0. Now E is formed in such a way that it has a value of 1, where 1 occurs in A as well as in B. For example, here I have 0 and 0, I written it as 0. I have 0 and 0, I written it as 0. Here I have 1 here, so I will bring this as 1. Here I have 1 in A, I will bring this as 1. So E is the new state that is introduced. So the new state should be created in such a way that it has got ones in the position where one was present in the transition states. So the combination of transition states. So if I take B, I had 0 0 1 in the third position. So in E also in the third position I have 1. When I take A, I had 1 in the fourth position. So E also has got 1 in the fourth position. So this is how we form the new state E. So now we are going to introduce the state E in between A and B. Similarly, when I talk about B and C, so B is 0 0 1 0, C is 0 1 double 0. So let me introduce a new state between these two. Let me call that state as F. So F is created in such a way that it should have 1 in the position where ones is present in both the transition states. So both the transition states are B and C. Here I have 1, so 1 will be retained here. Here also I have 1 in B, so that is retained. The other two values are 0. So similarly, I'll introduce this state F between B and C. Likewise, when we talk about D and C, so D is nothing else but 1 triple 0, C is 0 1 double 0. So finally, the new state that comes between D and C, let's call that state as G. So G is 0 0. Here I have 1. Here I have 1. So this is G. So the new state G is introduced between D and C. So there is one more transition between D and B. So let me take the transition. So D is nothing else but 1 triple 0, and B is 0 1 double 0. Sorry, B is not 0 1 double 0. B is 0 0 1 0. So the new state that comes between D and B, let's call that state as H. It's nothing else but 1 0 1 0. So we'll be introducing H in between D and B. So likewise, the last connection is between A and C. So A is given by 0 0 0 1, and C is given by 0 1 double 0. So we have to introduce a state between these two states A and C. So let's call that state as I. So it is 0. I have a 1 here, so this will be 1. It is again 0. I have 1 here, that will be 1. So it's typically an OR condition between A and B that gives E. Similarly, an OR condition between D and C that gives C. So you can take the logical OR condition between any two states. So I will be introduced between these two states. So we are going to draw the new transition diagram. So if you want to draw a new transition diagram, I have A, then we have B, then we have C and D. So A to B is through E. Similarly, B to C is through F. And similarly, D to C is through G. And B to D is through H. Let me draw H between B and D. So it's bidirectional. So here also it is bidirectional. So likewise, the last thing that is left out is A and C, which is through I. I is here bidirectional. So this is a newly formed transition diagram. So the bit values are A is 0001, B is 1000, C is 0100, B is 0010, H is 1010, and I is 0101, F is 0110, then E and G is left out, so E is 0011, and finally G is 1100. So with the help of this transition diagram, the final step is to redraw the flow table. So if you take the flow table here, I'll redraw the flow table. So we have introduced many states, so E, F, G, H, and I. So from A to A, there is no change. So I have A here. From A to B, we are going through E. So A to B is through E. So let me write the inputs first. Sorry, I forgot it. So A to A is fine. A to B is through E. So A to E first and E to B. Then A to C. A to C is through I. So I, then I to C. And last is also A to C. So that is I through. So likewise, the second row is B to A. B to A is also again through E. So B to E and E to A. So similarly, B to B is fine. Write it. B to C is through F. So B to C is through F and F to C. So similarly, B to D is through H. I'm just going from B to D. So B to D is through H, B to H, and from H to D. So likewise, the third row, C to A, C to A is through I. So it is through I and I to A. So C to B is through F, F, and F to C. C to C is fine. You can keep it as it is. Now C to C again. Okay. The fourth row, D to D is okay. D to B. So D to B is through H. D to B is through H and H to B. So the third cell is D to C. D to C is through G. Through G. Sorry, G. Not here. So it is D to C is through G and G to C. Yeah. And finally D to D itself. So that's it. We can just mark the other cells as don't care because we are not going to use them. So this is the newly updated row table which does not have any race condition. So this is how we do one hot race free state assignment. So if you have any queries, please do comment on the comment section. We would like to answer your queries. I'll see you in the next video. Thank you.